R is freely available software that allows you to do statistical analyses, and it's what we will use for all analyses in this class. Most of you all indicated that you had had at least some exposure to R in the past and felt somewhat comfortable with it. And so some of today, or a lot of today, will be familiar to you. But some of you all indicated that you had had no exposure or very little exposure to R in the past, and so today's going to be a new adventure for you. I included some primers on the course website, some links to some primers on the course website to give you some more practice and more exposure to using R if you need it. And so hopefully you've worked through those primers by now if you need to. In addition, this book is a very good and gentle introduction to R. It's very slender and you can work through it in a matter of days. And so if you are very uncomfortable with R, then you might get this from the library and work through it. By now, you should have downloaded R and RStudio onto your home computer or wherever you're going to be accessing this class. And as of today, the 14th of January, 2021, the most recent editions are R 4.0.3 and RStudio 1.3.1093. For those of you all who have used R and RStudio in the past and already have it installed, make sure that you've got the most recent version installed. So what's the difference in R, RStudio, and RMarkdown anyway? R is a programming language and a software environment. RStudio has a graphical user interface that allows you to basically use R in a much more user-friendly manner. And I find it has a lot of better options for some things too. And so that's what we're going to be using for this class. You have to have R installed in order to use RStudio. RMarkdown allows you to create a text document with embedded executable R code, and that's what you're going to use to make your weekly homework assignments. It comes already installed in RStudio, and so installing RStudio means that you will also already have RMarkdown. In addition to installing R and RStudio, you're also going to need to download the data files that we'll be using in this class. But you do not need to put them in the R or RStudio folder. In fact, what I suggest is you create a new folder on your computer with this class name, and you go to the course website and you download these data files to that folder, your class folder. These data files will have either a .r or a .csv extension, and there's also a Word document that explains the provenance of each one of these data files. I'm still writing lectures, and I may still have more data files to add, but if I do, I will let you know. So when you first open RStudio, this is what it looks like. I mentioned in the first lecture video that I'm working from home. I'm shooting these videos from home from my old laptop. And it's one that doesn't have the capacity to have a graphics card that is advanced enough to allow me to shoot a live video showing you things live in R. So as I'm programming in R. We have the live Zoom sessions on Thursdays where I can share my screen, however, and you all can share your screens too. That will be a good substitute for that. But for these lecture videos, I have to show you static images. And so that's one reason why I've made very detailed lecture notes available to you on the course website. That, and also because having very detailed notes will better serve you in the future. So here are some important steps to remember when working in R. As you've worked through the lecture notes for today, you will have more details about each of these. The first of these is you open up a new script which will be saved as a .r file. You'll need to set your working directory to your class folder where the data files are. You'll need to install packages only once, but you'll need to library every time. And in both the lecture notes and in these videos, I will set apart R code in a different font, in a Courier font. And in the lecture notes, I'll also use line shading. And then finally, remember to save often. Things can crash, and so saving often means that you won't lose your work. Okay, so here's another screen capture, and it shows something very important here. Notice how, let me see, get the laser pointer here. This is where I set my working directory, okay? And all of this path name, blah, 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 goes to where I have the data files for this class. You can copy and paste that from the window, the URL of the folder location. But when you do, the slashes will be in the other direction. And R likes for them to be in this direction. So sort of lower left to upper right. And so you have to manually change them. At least that's true in PC. In Mac, that may not be the case. In fact, I've heard that in Macs you don't need to do that. So at least in PCs, make sure that your slashes are facing in the right direction. That's just a weird thing with R. So slash directions, important. The other thing is any line or any phrase that starts with a number sign or a hashtag sign or the pound sign, that is code that is not executed, and that allows you to add notes. And so annotate your scripts extremely extensively. Use a lot of detail. Make copious notes, because you'll think, oh, I'll remember this. No, you won't. I promise you won't. These notes will save you. So here's a list of packages that we'll be using at first. And by convention, package names in R are italicized, which is how I denote them here and in the lecture notes. Later on in the semester, we will also use a few other packages. And please note that package names are case sensitive. So these packages are ones that were developed for various functions. Some of them are very broad, like vegan, for example. That's probably the best known community ecology analysis package that's out there, and it does a lot of things. Whereas other packages like PLYR, they are very specific in what they do. But having lots of packages allows us to do lots of things. For more information about what available packages there are, you can go to R's website, which is called the CRAN website. And there's a list of available packages by name. I have these links on the course website. And there's also a list that's maintained for ecology as well. Each package will also have documentation, typically as a PDF file, on the CRAN website as well. Okay, so one of the first things you had to do today was to read in a data file called bryceveg.R. And by following the instructions from today, here is the code down here. And this part here, header equals true. If you want, you can double click on this and open it just with a text editor, and you'll see that it has headers. It has words that indicate what the columns mean. And so that's what this header equals true means. Okay, so once you read that thing in, you'll see that it populates an entry over here in the Global Environments window. And if you click on that, what will happen is a little tab will come up over here. And if you click on it, it'll show you the data. And so you can see here that this is a site by species matrix. The sites or the sampling units are the rows and the species are the columns. And this is R's preferred way of dealing with data. And we will work with some data sets later on in the semester that do not conform to this, and you'll learn how to deal with that. But this data set is one of a pair of sister data sets. There's bryceveg.R and brycesite.R, and they're both part of the Lab DSV package. And they are from Bryce Canyon National Park in Utah. And this bryceveg data set here has vegetative cover for each one of these species, these sort of species name abbreviations here, for each one of these sites here. And so this is a site by species matrix. It's one of the main types of data that we need to look at with ecological communities. The other, recall from the first lecture, is going to be a site by environment matrix, where you've got environmental variables measured at the same sites where these species were measured. There are 4 types of data in R, and it's important to go over this because sometimes you cannot just mix and match data. And so you have to understand what your data set is in order to be able to do certain things. And if you don't understand what kind of data you have and you try to do something in R is going to be like, I can't do that on that type of data, and you may not understand that until you understand these 4 types of data structure in R. The first type of data, these are vectors, and I like to think of them as just rows of information. They're one-dimensional sets of a single data type. By one dimension, I mean like a row or a column. And by data type, data types are categorical, words, or they're numerical. Okay, and so a vector has only one or the other of those. A data matrix, on the other hand, is two-dimensional. It has rows and columns, but it also has only a single data type. So either numbers or words. So with a matrix, you can query it by saying the matrix name. So veg, for example, that we just created, read in from bryceveg.R. If we want to know what's in row 23, column 48, and that's the order, row, column, then you just type that into R and hit enter or run up in the corner, and it will return the value of that cell in your data matrix. So if you want, you can pause the video and do this right now and see what is the data value that happens to be sitting at position 2348 in veg. It happens to be 0. Okay, so that's a data matrix. A data frame, on the other hand, can be one or multidimensional sets, and they can have different data types. This is where you can mix numbers and words. And then finally, lists are self-explanatory. Now you're going to read in the sister data set to bryceveg. This is brycesite.R, and you can see the code here on what you need to do here. And then open it in the Global Environments window and examine it, just like you did with veg, and take a look, and then answer this question. Why is veg a matrix, but Bryce a data frame? And if you want, you can pause the video now and go answer that before I move on and discuss. The answer is veg has only one data type in it. It has numbers, whereas Bryce has more than one. It has both numbers and text, and that is the definition of the distinction between a data matrix, veg, and a data frame, Bryce, here. So here is what Bryce looks like, and here are the sites. Again, here is the rows, and here we have different environmental variables as the columns. And you can see that some of them are text and some of them are numbers. And in the notes today, I have where you can find more information about what each of these means. So this is a site by environment matrix. And so we have the bryceveg and the bryce site by species, site by environment data sets. And the bryceveg matrix and the bryce site data frame are linked by having data from the same sites, the same locations, these rows in each of them. And so we'll start by doing analyses on each one of these types of data, a site by species matrix, a site by environment matrix. We'll work with each of those independently at first, and then we will combine these data sets based upon their shared component of site. Okay, so to create your homework file, you'll create an RMarkdown file. So you'll go to File, New File, RMarkdown, and then this box will appear. Obviously, it will not have my name in it. And then you will give it a title here. I've just called it Intro. And then make sure that you select this radio button down here for Word. That tells RMarkdown that the end product will be a Word document. And that Word document is what you will email and turn in for your homework. And then once you hit OK, then this box will pop up. And it is automatically populated by RMarkdown. You can see up here the name that I gave it, my name, and then today's date, and then everything else is automatically generated by RMarkdown, and you can read through it if you want. So the RMarkdown file is sitting on top of your R script. The R script has a blue logo here, and then the RMarkdown file has a red one. So what I do is I toggle back and forth, and I go to my R script, and I select all, and I copy it. And then what I do is, notice here these little shaded lines. There's 3 markings, there's a curly bracket, and there's an R, and then some words, some more words, and then there's 3 more of those little marks right there. Okay, go to that and get rid of all of the words. Just keep the 3 marks, the curly brackets, and the R, and then the other 3 little marks here. And then down here, all of these other words, similarly, get rid of them. Okay, delete them. Then what you do is you paste that script that you had copied from your R script here. You paste it in between the 3 marks in the R here, and then the 3 little marks down here. These little marks are called carets, by the way. And this stuff in between these marks tells RMarkdown that this is executable, that this is code that can be done, performed. So paste your script between the marks in the R and the little marks at the bottom. Now here's something strange and peculiar about RMarkdown. It does not like having install packages present, and if you try to run it, it will not work. So you either have to remove this line from your RMarkdown file. You can keep it in your script, but you have to remove it from your RMarkdown file, or you have to set it aside and denote it with the little number sign. Remember, that's something that indicates a note and not an executable script. And so that's what I do. I just put a number sign in front of any install packages code that I have in an RMarkdown file. And so now, once you have everything, you can add more text above. Let me get the laser pointer. You can add more text above, below, or whatever, or you can denote more text in here. Just remember to use the number signs. And then, in order to create the file, see how it says knit up here? You're going to click on that, and the result will be a docx file, a Word document that will be automatically saved into your class working directory. Your RMarkdown file can then be saved, and it'll be as a .rmd file, and you can save your script as a .r file. Okay, so here's your first homework assignment, and it's going to be due to Aurora no later than 8 a.m. on Monday, February 8. Follow the instructions in the embedded notes. And what you're going to be doing is you're going to be using a data set that R has. R has data sets of its own. And one data set is on irises. Iris is the genus of a flower, and this data set includes information about 3 species. These 3 species here, beautiful things. And it talks about characteristics of petals and sepals. And you can see differences in the length and the width of these 3 species here just from these 3 photographs. And this assignment is meant to be a demo and practice in using R and showing you a few things that R can do and give you a bit more practice in using RStudio and RMarkdown. But it's not any kind of multivariate analysis in it yet. Instead, it's really designed to get you thinking in terms of graphing data first. Make a graph, examine it, and then try to interpret what that graph means. And so what you're going to be doing is you're going to be making and interpreting histograms and box plots of these sepal and petal widths by species. And you'll also do an analysis of variance to determine whether there's any statistical significance on this. And you'll answer 6 questions that are in the assignment and the lecture notes, and then you'll turn in the Word file from today from your RMarkdown that is the result. So if you have any questions, remember that I will see you via Zoom on Thursday.